Hey class, this is Gigi from Kauai Community College. We're looking at, in this problem, limit at infinity. So we're taking the limit as x, or our variable, is approaching infinity. So I'm going to go ahead and look at the one on the right first, and that is the limit as t goes to infinity of, and when I see negative exponent, I can go ahead and rewrite that. Negative 14, a negative number, does not get moved. It stays at negative 14 on the numerator. And the one with the negative exponent can be moved down to the denominator to have positive exponent. So when t goes to infinity, we have negative 14 divided by a huge number, and negative divided by a huge number, negative divided by a positive, is going to be negative, and then a number, a finite number, divided by a really big number is going to be approaching 0, and 0 is 0, so really we don't need to say negative 0, right? So then we can say that the limit as t goes to 0 of negative 14 t to the negative 5 is equal to 0. Okay, as a matter of fact, we will think that the limit as x goes to infinity of a number divided by x to any power is going to be 0, because we have a finite number divided by a huge number, and that's going to become really small, and it is going to be approaching 0. Okay, just like we know in the parent graph of the reciprocal function, right? So if we have the parent graph of a 1 over x, it will look like this. And then if we have 1 over x squared, it will look like this, right? Either case, our function is going to be approaching 0 when x goes to infinity or positive infinity. So what we can really write right here is when x is approaching positive or negative infinity, a number divided by x to the p power is going to be 0, as we can see here. Okay, now using that concept, we will be able to find the limit or the infinite limit of functions that are a little bit more complicated, like this one. Okay, so here, using the same idea of 1 over x to some power, I want these to look like that. So I'm going to go ahead and divide both the numerator and the denominator by x to the 4th power. And when I do that, this becomes limit as x goes to infinity of, what do I have here? 3 over x to the 4th power plus 6 over, and you know what, I shouldn't write slashes. I call them lazy fractions, and they don't really look nice, so let's just write it as a real fraction here. 3 over x to the 4th power, and 6x divided x to the 4th power is 6 divided by x to the 3rd plus 4x to the 4th power divided by x to the 4th power is 4. And then on the denominator, x to the 4th power divided by x to the 4th power is 1. How nice that your denominator now is a number, right? Number 1. So we can apply the concept of x going to infinity of 3 over x to the 4th power is going to go to 0. And the same thing, 6 over x to the third power is going to 0 when x goes to infinity. So all we have is 4 divided by 1, and 4 divided by 1 is 4. So we can say limit as x goes to infinity of 3 plus 6x plus 4x to the fourth power over x to the fourth power is going to equal to 4. Okay, so remember when taking limits at infinity, we relied on this fact right here. Okay, number divided by a huge number, a constant divided by a huge number is going to go to 0.